know, we usually go live, which is Absalam. He's always helping us streaming to YouTube. So hello, everyone. Thank you all for attending. My name is Mohanraj. I'm a technical lead trainer at AirAsia, and I will be your host for today. So today we have a very cool stuff happening and cool speakers and all the friends joining us. Let me just share my screen to share my presentation. My slides, I'm not giving a presentation today. You guys can see my screen? Nice. Okay, so today we have two speakers. We have Kaushik, which is one of the member who's helping us building this community with Absalam and me and Gauhar. And we have Belal. Belal is used to work in Malaysia, and he just joined us all the way from Netherlands through Google Meet, of course. So before we get started with our talk, just some quick call outs. If you have any question, leave it in the comments on YouTube or on the Google Meet. And if you are not talking or asking any question, please help us to mute yourself. And after this session, we will stop the streaming on YouTube, and we can just have a networking session talking about anything you guys want, from cloud to music to startup, so anything. And if you are hiring for your team, you can as well do that in the networking session. So let's start with our first speaker. Again, Belal. Belal used to work here in iFlex, that is based in Kuala Lumpur. And he has a very rich experience in streaming and videos. So if you have any question related to that, you can reach out to him on LinkedIn or Facebook. Pretty sure he will answer you. So today he will talk about an army of Lambda. It's a very interesting topic. So let's see and hear what Belal has. And again, guys, if you have any question, even you can unmute yourself if you want to just ask it directly, or just leave it in the comment and I will pick it up and ask it for Belal. So I will pass it to you from here, Belal.
Cool. Let me share my screen. Yeah, let me know if you can see my screen. Yes, I can see it. Can you see my screen?
Yes. Yeah, I can see it.
Cool. So thank you, everyone. I'll be looking this way because this is my big screen. I will not be looking at you. Sorry about that. So my name is Belal Haikal. I'm currently working as a senior software engineer in the Zone. We're going to be talking about how the Zone. So the Zone Hub has a lot of Lambdas. They mostly operate on Lambdas. So they have. We're going to discuss how the Zone is handling those Lambdas. Since it's a Chinese New Year week, so Happy New Year, and hope you're having a good year now. So about me, as I said, I'm working in the Zone. Before that, I used to work as a solution architect at Talpa Network. It's a Dutch company here in the Netherlands. And before that, I used to work in Malaysia at iFlex. So the Zone is, for those who don't know it, is a live streaming company for sports. So we provide live stream and video on demand for sports, not only football or UFC. It is many other sports. So we have NFL, NBA, Formula One, whatever you'd like. And we call ourselves the Netflix for sports now. So let's go back to our topic. It's about Lambda. First of all, Lambda is a compute service on the cloud that is managed by AWS. and it is scalable. It is as I said, it's managed by AWS. You just have to write a little bit of code, put it on Lambda and run it, and then Lambda will execute that code. It is we call it Lambda function because it's preferred that it does one function only. So it does only one thing, and once this one thing is done, Lambda is going to die. We're gonna discuss this later. So Lambda is now growing really rapidly, and it is taking over the servers, but it has a little bit of limitation. So Lambda can only run for 5 minutes, and it has limited CPU and memory. Also, Lambda does not run 24/7. So it runs, as I said, for 5 minutes and it dies. It's not constantly running. But how is this Lambda taking over the servers, as I said earlier? Basically, it's Lambda needs something to trigger it to get it running. So it needs an API gateway, which is an API call to run it, or it needs an S3 notification. It needs an SQS, which is a queue system, or SNS, which is a notification system, or a DynamoDB to get it running. So how many lambdas does the zone have? Basically, the zone has, as I look, it has around 100 lambdas. If we multiply those with 4 regions that the zone currently operate on, and we have around 400 accounts. So the answer is, I cannot tell the answer. It is a lot of lambdas. So we have tons of lambdas. They're all running on AWS. So how is Lambda replacing the servers? So let's look at a user. It will have a user journey. So it will have a Lambda for login, a Lambda for registration, checking the tokens, a Lambda for verifying the tokens, subscription, payment, etc., etc. Tons of Lambda. Everything on the back end runs on Lambda in the zone. All the ingestion pipeline. Yeah, we have tons of Lambda in our system. Okay, so if we have this amount of lambdas, as I said, we have thousands of lambdas. How does the zone is able to handle all these lambdas? Well, basically, the golden rule in the zone as developers, you built it, you own it. So we don't have a DevOps team that managing our DevOps, our infrastructure. Our DevOps team, they provide us with tools to easily manage our infrastructure. Me as a developer at the zone, I manage the lambdas I build. And I think this is a concept that people should, or companies should start moving towards, is that developers should manage infrastructure instead of having one DevOps team who focus on that. The second part is we have Lambda layer, which is a great feature in Lambda. Let's discuss about it a little bit. So we have the user, and the user is invoking multiple lambdas, and inside the lambda there is a code, but there is a common code inside all those lambdas. Like, for example, a code for logging, a code for monitoring, a code for third-party libraries. Let's say you have a CMS, so you always use that same code for the CMS. All those libraries, they take size from your Lambda, and they take processing power. So you can uh, accumulate those libraries and put them on a shared. You can consider it as a shared folder for all the Lambdas, and then those Lambdas can access the libraries and invoke them or call them, run the code inside of them. So this is one of the great things that makes it easy for the developer to ignore the the code that is consistent. Let's say, like, you have to write logs code always. You have to write code for monitoring. So now I have to only focus on the logic inside the Lambda and forget about those codes because it's just calling a library. Um, the second part is for monitoring. We are using New Relic. As you can see here, we have the traffic per region. We have which shows we have, as I said, we have 4 regions our Lambda are running on. So here it shows you which region it is. The traffic is mostly coming from. Of course, this is not production data, so it's fine for you to look at it. We have the number of invocations, how many times this Lambda has been invoked with this certain of time. We have the maximum duration, so how long this Lambda has been out. For example, if you can see the top Lambda, we have it's running for 14 seconds. That is too long for an API call that is waiting for 14 seconds. And this gave me an insight that, oh, there is a problem with this Lambda. Why is it taking so long to respond to the user, for example? It gives really good insights about the Lambda. And average concurrency, which is, as I said, Lambda is scalable service. So how many Lambdas are running at the same time at this period of a specific period of time? And finally, is the Lambda returning errors? So I can monitor and see how many errors are occurring within a period of time as well. It's a New Relic is a really compatible and good tool if you want to have good insights about your Lambda. And finally, we use logs.io, which is a service, a third-party service that accumulate and aggregate the logs. So, and we use it for logging instead of CloudWatch. The problem with CloudWatch is it does not have actually it does not, yeah, it's hard to search inside it. Plus you have to go to every region and check the log in every region, where logs.io aggregate the logs and put them all in one place. We can easily find if there is an error or follow up with data. Of course, I cannot show you our logs. So here is John Cena telling you can't see me. And to build those Lambdas, I recommend you can always go to the console, click your way into it, and copy paste the code. But that's not the ideal way, especially if you have this huge amount of Lambda and you have to replicate the same work over multiple regions. So I recommend you to use serverless, one of those libraries, serverless, CloudFormation or Terraform. My favorite is serverless, but yeah, the rest also work as fine. I believe that is all from the zone and how we manage lambdas. If you guys have any questions, please let me know.
Nice. I have a couple of questions actually.
Go for it.
Nice. So first one, why do you guys use that third party for the logs? Why you just don't use CloudWatch? Because I got your point, but why we don't just send it to Elasticsearch and just because I saw the layout is very similar, right, to Elasticsearch.
Yeah, true. It is really similar. I think they are using in the background Elasticsearch. I don't know why we are using this. It's there when I came. So
Right. Any other question, guys? Before I ask my second question. Okay, Delane, go for it.
On it. Hey man, thanks for the talk. I've been using Lambda for the past, I think, 6, 7, 8 months, but I'm facing a lot of the slow response issue and the inconsistency with the response. How do I get rid of that, or how do I solve it? The second, highly appreciate if you could explain the difference between invocation and the current execution.
yeah, so to speed up the slow response, you should keep your Lambda warmed up. There is a way where Lambda will not die. So as I said, Lambda lasts for 5 minutes and then it will die. When you want to invoke it again, it will take few milliseconds for it to be activated and then respond, run the code and then response to the user. To do that, you should keep your Lambda warmed up. You can do that, I think, using CloudWatch, if I'm not mistaken. So your Lambda will be in idle situation. It will not 100% die. It adds a little bit, just a little bit of cost to you, to your infrastructure, but it's really low amount of cost.
Cool. Other question is the difference between invocation and the current execution. Excuse my stupid question, but I really don't know.
Definitely take your time, man.
Yeah. It's definitely. Invocation is when you send a request to Lambda and then the Lambda will wake up. But current execution is you have invocation is how many times you triggered and woke up a Lambda, but current execution is how many Lambdas running at the same time. For example, if your Lambda finish your code within 2 seconds, it doesn't die. Your Lambda still warm up. But so if you have a second request, it might the same Lambda might respond to your second request. So your current execution is only one Lambda, but you have 2 invocations.
So that means multiple API requests will be handled by one executed Lambda. Is that correct?
Yeah. If it's fast enough to handle that, yes.
Cool. Will I be charged based on the invocation or based on the concurrent execution?
Sorry, again?
Will I be charged based on the invocation or the current execution?
That I don't know.
Okay.
You pay per the duration that you are using. So the idea is what Belal mentioned is really cool. The other thing is, imagine that it's a container running, and this container will stay running for at least 15 minutes. Okay, and this container itself is invoked multiple times, like an API on it is invoked multiple times. This is the idea. Each API call, let's assume it's an API call, each API call inside it is built separately. Okay, so you could have, like, let's say, one underlying piece of infrastructure, which is running your Lambda, but then you would have 100 Lambda functions that are running on the same, in a way, infrastructure. Okay, imagine it like this.
Wait, you make it complicated. Again, sorry.
Okay, so here's the thing. Imagine you have a Docker container running, okay?
Okay.
And then inside it, there is an API, and this API receives calls. Okay? Lambda function is like this. It's just that it's a container that runs for at least 15 minutes. Okay? This is the first rule. The second thing is it can receive multiple calls at the same time. Okay?
Okay, got it.
Cool. Now, every call to this is billed separately based on the duration you spend and based on the memory used.
Cool.
Yep.
Cool.
Nice.
Okay.
Got it, Delaine. You have any other question? I think you guys can have this discussion because the talk was a bit short, so we can just talk a lot about lambdas if you have any question.
Question, please.
Okay, then I'm gonna check. Provision concurrency versus warm setup.
What do you mean warm setup?
So which one do I go with? Provision concurrency or warm setup, the one just Belal mentioned? So to keep my Lambda warm.
So what is provision concurrency? It is them running more than one Lambda at the same time, you mean?
It seems like you allocate, for example, 10 Lambda that's run 24/7.
Yeah, so no. The provision concurrency is that AWS will book 10 Lambdas for you, for example, and even if, so let's say you have a pool of Lambda on every AWS account. There's by default, I think it's 1,000 Lambda. So if you have a service that is taking over all those Lambdas, that means another service cannot use those Lambdas.
Oh, got it.
So if you have to allocate, if you want to make sure that this service doesn't go down, you have to allocate like 10 Lambdas, and then, or let's say 100 Lambda, then it's 900 Lambdas will be the pool for everything else, and then you have 100 Lambdas for this one. The warm Lambda is that your Lambda is active. It's not dead. It doesn't take much time for it to be invoked.
Cool.
Just let me go into this because this is a very good question actually, which I face a problem with in one project I was working on. So the provision concurrency, just think about it this way: when you have your account, right? Your account comes with the 1,000 default concurrency, right? So when you provision concurrency, actually you are not provisioning more than 1,000. So what is happening? Let's say you have two Lambda functions, one, for example, doing something and the other doing something. And you think this function is open to the public, so you will invoke this function more, right? So what we usually do, we provision or we reserve concurrency for this function only. But you can raise a ticket to increase for the whole account. But I have a question actually to Belal, because I start seeing this problem a lot with Lambda.
Thanks.
Yeah. So Belal, this question for you. So Lambda is very cool, right? But what I'm seeing right now, like when you scale a lot on the Lambda and you open it to the public, you are not using it internally, right? And a lot of people like calling this Lambda, you start facing problem with concurrency a lot. So we face a problem, we raise the ticket to increase it from 1,000 to 2,000, then we face the same problem. Then we redesign our architecture in a way that we call this Lambda function less, right? Did you, and I think me and Absalam and Kaushik, one time we were talking about the same concept. Did you face anything like regarding this?
Well, we faced it. I mostly faced it in iFlex before, because iFlex had one main production account, and we were also building it on Lambdas. But here in the zone, as I mentioned, we have 400 accounts, AWS accounts, more than 400 AWS accounts. So we have allocated account for each part of the system. So reaching 1,000 Lambda, it is not that easy when we spread it over. When we say 400 accounts, that means we have over 400,000 Lambda pool as a beginning, and then we can increase it as we require. So eventually we have near 1 million Lambda running.
Cool. That's cool. Any other question, guys? We still have some time. I think we have Mustafa. You wanted to say something, right?
I'd like to ask one question for Bilal. Yeah. Thank you, Bilal. Thank you.
Bro, don't do an accident while
one
driving.
question about one Lambda. Yeah. So one thing, is there any way that I can share between multiple Lambda, like one resources, or like I can, like, for example, or I save one file, then I share between multiple Lambda this file? Is there any way that possibility?
Yes and no. So you have to use another service, which is S3, if you want to share a file between two Lambdas. If you're caching your, well, there is a way, but it's not really trustworthy because you have kind of a small shared hard disk between all the Lambdas that you're running. So if your code is, you just have, like, if your code running all at the same time within the 5 minutes, you can access that temporary folder inside the Lambda, but you have to make sure.
The issue, no, I don't want this, because the issue is I don't want my Lambda taking more than 15 minutes. Okay, so what I'm doing, I'm saving the status of each Lambda, what is doing. Then the other Lambda, when it's warm up and start again, the other one hand over, so it will see the last status, let's say, for the last Lambda. This is how it's working.
Well, yeah, I recommend you to either use S3 for that or DynamoDB if you want to have the status on a DynamoDB. But I personally recommend you to change the whole infrastructure for to have it as what is a step function, which is one Lambda will call the next Lambda. So you will split your Lambda, not doing multiple functions at the same time. It will do one thing, and then it will invoke another Lambda and give that next Lambda the status and the information it needs, and then the next Lambda will do the next step.
Okay, I'm not sure, is because I'm using Zaba, I'm not sure if you're aware of Zaba with Python.
No.
But this one, like package, it's handled for you all the warming up, even it's keep it warm for all the time for 15 minutes, you keep it on. So the issue is this Zaba is not allowing me to access this shared, or like say the step function. I'm not sure, maybe I'm not aware of how it's worked, but I searched about it, but I couldn't reach. But the only solution that you are mentioning is the step function that can be used, but I have to build everything while Zaba is handling everything for me.
Yeah, I don't really know about Zaba actually. As I said, I've worked with serverless, Terraform, and CloudFormation. You can easily build those stuff on it.
Okay. Thank you, Bilal.
Awesome. Any other question, guys, related to Lambda, or you want to share anything about Lambda, maybe?
One more question, if nobody else has, then I will go ahead.
Okay. I think that's why Dalain is joining us today. He just wants to ask his question and go back to work.
I want to know, Bilal.
Go ahead. I'm enjoying the conversation.
Okay, my current startup application serve the C region. Okay, and it's quite fast. I mean, the response is quite fast. Unless sometimes Lambda acts up. Okay, so we are launching Canada soon, and since I'm in Turkey now and I request whatever the API, I see that it's slower because of the bandwidth or because of the request, right? So if I want to launch Dimbos or my current startup in another region, can I just duplicate the same? Can I support one Lambda support multiple region, or how does it work?
Well, if you're starting it in a new region, it's better that you create a Lambda, the same Lambda code, everything in that region, and then you manage your routing according to the region to which Lambda.
within the same account, or I should create another?
No, it's the same account, just different region. For example, in the zone we have 4 main regions, which is US West, US East, Frankfurt, and Japan.
That means I need to duplicate Lambda and RDS as well?
No, you have Lambdas and API gateways duplicated in every place. But the RDS, I don't know how actually networking. I'm not really good at networking in AWS, but I believe in RDS you can tell which region and then redirect to the nearest API gateway for that region. I'm not quite sure how actually. If someone has experience in it, please let us know.
Actually, the question comes about latency when you speak about RDS here. So if you wanna provide better experience, you either have a caching layer or you split per country or per region database.
You mean one? Okay.
A caching layer would be like Elastic Cache, for example, or having DynamoDB, or whatever.
So in a way, I need to create a new set or stack per region, kinda.
Yeah, to a certain level, because you will need some kind of networking also to the RDS, because I assume you won't open it to public. You will put it as private. Then you will need to have a VBC in every region, and you have your Lambda connected to that VBC, and then you have your VBCs connecting with each other somehow, either via sharing a subnet or either via sharing a VBC peering connection.
Got you.
Because it's complicated.
Sorry,
hire a consultant.
Oh, yeah.
Here is my number.
This is your chance to have free consultation, guys. That's why we are having this meetup. Yeah, but I really love it, Zalen. You should always join us, man. I love the topic you are opening. Actually,
most of your time is like within conflict with my training schedule.
Yeah. And I think this is the goal actually of the meetup, right? Like you have a problem with your startup or anything, and you come to the community, and people will be happy to help you, right? Any other question, guys? We still have one more question. If anyone want to share or say anything related to that, we have some people from Fave. We have some people from AirAsia. Faris, I think he's from AirAsia. AirAsia using GCP, but same concept. Kaushik is laughing now. Kaushik, you have any question? Guys, any question before we say thanks to Belal?
Good.
I think, okay. Thank you, Belal. I really enjoyed it, man. And if you have some speakers from Netherlands in your company want to share something, let me know. We can host it.
I think you should change the name of the user group. It's not only Malaysia now. You have Netherlands, Germany, Turkey, and
exactly. We have all around the world now, right?
Yeah.
We are a global
maybe
team
next
now.
time we do it special edition, right? Until the lockdown is finished. Okay, thank you so much, Belal. Definitely we will host you again here with a new topic in future.
Yeah.
Let me share my screen very quickly. So guys, we don't have any hiring announcements for today. But if you are hiring for your team, just scan this code, fill up the form, and we will shout out all the open positions in the next meetup. Okay, so I'll just leave it here for a few minutes, and you can find this on our AWS user group on Facebook if you want to scan it after today. Okay, and this is the most important part. As Belal today, he joined us from Netherlands. If you are in any country, you can just scan this code, fill up the form, and we will contact you. You can share anything about cloud and AWS specifically. Shouldn't be a very advanced topic. You can just share with us a very basic project you are working on, because a lot of new people joining us. So definitely anything or experiment on AWS, you can share it with us. So just share, scan this QR code, and we will reach out to you. I will just leave it for a few seconds if you guys. Okay, now let's welcome again. So Kaushik actually gave like a couple of talks in the past few months. He gave the recap reInvent, and now he's giving more in depth about AWS serverless and the new cool stuff that's happening with it. So Kaushik join us as well, me and Absalam, with the AWS user group community, which is this is the one we were building for the past 7 years, I think now. And he's helping a lot by bringing speakers and promoting our user group. So he's a director in Blazeclan, and Blazeclan is famous to work with the cloud. They are very active, and I work with a couple of their engineers in Astro, and they're doing great jobs. So let's welcome Kaushik again with a new topic.
Thank you, Mo. Appreciate
I will pass
it.
it to you from here. Let me just stop. Yeah.
Sure. All right. I have shared my screen. I'm assuming you see it well. All right. All right. Thank you, Mo. Thank you, everyone, for joining in. This one was on a very, very short notice to everyone. So, yeah, thank you for that. So today we'll be talking about Aurora Serverless. Some details around it. It was, on what has been the history of it, and more details specific on the service which is still under preview, which is Serverless V2, right? So you've been using some of the Aurora and Aurora Serverless. We'll talk about that and then share some details around it. So I'll keep it nice, quick, and crisp and short. We'll see if you have any questions, and then we'll take it from there on. All right. Okay. So this will be the agenda for the one, and I'll start off talking about 101 details on what would be the managed services and why the Aurora Serverless as a concept is in place and why it is helpful, right? So we have had managed database services. So right from, we have started off hosting it on EC2. Then on EC2, you have your AMI, which comes with pre-baked database servers, right? So you have those flavors which are available. So that what are the issues there, where managing it at scale, if there is need for storage scale up, and what are the concerns? If it needs compute scale up, what are the concerns? You need to plan for downtime and so on and so forth. Then came the next level of it, which was managed database, which is the RDS and the Aurora, right? Where everything, patching, the hardware, all of it is managed by the by AWS at the backend. But you just do the configuration, and even if a scale up is required, still downtime is there, but it's easy to manage, right? You reduce the overhead of using of having a DBA on your team, and that's a cost saving. So from there on, everything was there, but then came a new version of serverless database, right? So that was Aurora Serverless. Serverless, like Aurora Serverless, is not the very first, serverless database. We'll talk about the other versions that came through, but yeah. So then came the Aurora V1 and then V2, right? So all said and done, why do we need a serverless database? What is the problem statement? What are the what would it potentially solve? So the problem statement is basically database capacity management, right? And that's what serverless would address, or what is being addressed by the serverless databases across all cloud providers. So let's say you could have various workloads, spiky workload, have infrequent workload like these, where you had spikes then and there, and then you could have periodic workload. In all these scenarios, you would either provision it for peak, which would mean it would become expensive to host your database, right? Or you would provision less than peak, impacting your business, which you don't want. And or finally, which is optimal from a capacity management, but cost of maintaining it is high, which is manually scaling up by continuously monitoring it. So these are the issues with the database capacity management that has to be that is being addressed using Aurora Serverless, right? So a glimpse of what AWS did with this, they brought in Aurora Serverless. As I said, Aurora Serverless, is not the very first one. Aurora and the provisioned instance was launched in 2014, right? So this is your regular RDS instances, but AWS gave their own flavor to the MySQL and the Postgres flavors that they had and managed it. It's not serverless. In 2014, it was the provisioned instance, right? The reason I called this out here is I use this term provisioned instance later in the deck, and that's why I wanted to call that out, right? So in 2014, that came out, and then came serverless V1 in 2018. But as I said, DynamoDB, which is also serverless, was back in 2012, right? But it's a NoSQL, not an RDBMS database, which Aurora is. And for those who have been working with AWS for some time, would also recall another service called SimpleDB, which was there back then. Though I think it was launched back in 2008, if I'm not wrong, and it just died off. And many people who have recently started using it won't even know what SimpleDB is, right? So yeah, so as a serverless, the AWS has been trying various things, but in RDBMS space, this is the first flavor that came out. In 2018, it became generally available, GA, right? But we all, those who have tried to use GA, the serverless V1 version, would always know that you might not use it for production workload for many reasons, which we'll probably talk about and call out what the issues are, right? And then serverless V2 was launched in reInvent 2020 in December and is still under preview, right? So in V2, most of the prominent issues that were there in V1 has been addressed, right? So we'll talk about what those things are which has been addressed over here. So that is a brief history of what Aurora database has been and what it does, right? And just to note that Aurora Serverless supports two flavors, MySQL and Postgres, another one, I guess, but these two are the versions that are supported in V1 and V2. All right. So some details on Aurora Serverless service, and so that once you start using it, these are the terminologies and concepts that you should be aware about. So Aurora Serverless, basically like compute, you have your compute specs. For Aurora, you have Aurora Compute Unit, or ACUs as they call it, right? Approximately one ACU is about 2 gigabit of memory with corresponding CPU and networking capabilities. So which is like not a published thing, but they have it in there, saying that one ACU is such a value. With that, that is how you would say that I need so many ACUs to manage my database. Okay. Next concept is basically in Aurora Serverless, there is a segregation of the compute layer and the storage layer. And we'll talk about that in 2 seconds from now. The other services that you would probably see and get is auto scale startup and shutdowns. Whenever it's idle for some time, it can shut down, and then start up whenever request is triggered. Scale up and down both storage and compute, which is interesting, right? And because of the segregation that they have at the between the compute and storage, they can independently scale them, right? So all of this can scale. So now when we talk about scale up in version 1, right? In version 1, the scale up happens up in a form of doubling. So you double up from 8 to 16 and come to that. So let me talk about the storage scaling. So in storage, the entire data is stored across 3 availability zones, and basically it has 6 copies. So this gives you a good representation. So this here, right here is your okay. So this right here is your compute and all the segregation, and this is your shared storage volumes. And if you would see, in every AZ you have 2 copies stored for each data that is written. So basically 6 copies across 3 availability zones, and the database uses 4 out of 6 quorum for write availability. By that I mean that even if 4 of these copies are available across 2 availability zones, it will commit that and it is good to go, right? Even that also accounts for if a complete availability zone goes down, your data is still secure and will be accessible with the minimum latency, right? So that's on the storage. So that's how you scale. And similarly, as soon as you are reaching a certain limit, the storage can expand, and then you could have more data and storage into it, right? So that's that. So what is compute scaling now? So compute scaling, basically you could have multiple writers and one writer and multiple readers, right? You can have up to 15 promotable readers. The word that they use is called promotable readers. Again, is basically calling out that you have one cluster endpoint writing it to the writer node, and which writes to multiple storages here, right? And then you could have multiple promotable readers which can read from your storage from every availability zone. And the word they use, promotable, is basically that it is it becomes a failover ready, so that if in case a writer instance goes down in a particular AZ, one of the readers will be promoted as a writer automatically, and it will fail over with sub-zero downtime. Basically, that is what is the commitment there, right? And the cluster endpoint, all of that manages is the same. So that's the concept behind it. So there are various ways, you could potentially use these readers for, load balancing your reads. So you could have multiple application read operations to different endpoints, and you can create a custom reader endpoint to multiple readers and to the same data. So in that way, you're creating a separate reader pool for each of your applications without compromising on that. So that's one cool capability that you could do using the Aurora Serverless cluster. All right. So that's on serverless in general, both V1 and V2. Some details around V2 which changes here and which we'll talk about, right? So a quick introduction. So credits to AWS reInvent videos, from which I've taken all these images. So a credit goes to that. And another blog which I read through for all this detail, right? So yeah, so I just wanted to call that out. So basically, now there are 4 features that AWS called out. So first one being that, it can scale instantaneously. So one major point that you would remember earlier what I said, that your scale up for compute, if you had 4 ACUs and you needed more compute into it, basically you would go from 4 to 8, even if you needed 5, right? So it used to double up from 8 to 16 and so on and so forth. So that's how the scale up and scale down happened in version 1. But here, and it had a pool of instances, pre-warmed instances, which would add in and go out, and it had a lead time. So it's so to say a cold start between it, without any downtime there as well. But again, it used to take some time for scaling up. V2, they claim that it is 15 times faster as compared to V1 in scaling up and scaling down as well, right? So in scale down, they have a mechanism of step scale down, but that we'll talk about as well. Okay, so that's a number. So as compared to V1, where it doubles up, in V2, basically you can scale, increase the capacity at 0.5 ACUs, right? So that's what this is called, the scale in fine-grained increments. Basically, your instance capacity, you can scale it up from 4 to 4.5 to 5 based on your requirements. So that's the smallest ACU unit that you could use, right? So that's on the scaling up in fine-grained increments. And then, of course, they have all the capabilities that were available on a normal Aurora provisioned instance, right? Like multi-AZ setup, global databases, read replicas. All of this is something that has been addressed in this V2, right? Which is available, all of it in V2. And the last part, which they say is up to 90% cost saving when compared to provision for peak load. So this one, you will have to read the fine line here. When I did some comparison using the calculators and on what could be, this is something that it doesn't match up to that. It is not 90% cost saving as they claim it. But here specifically, it is saying that 90% when compared to provisioning for peak load. So that's a fine line. I'll share some metrics on and cost units and some scenarios around it. Yeah. So the serverless scaling, this is one thing that I want to showcase, like how would it scale based on your requirements. So if you had a one level increment that you wanted from here to here, you could get this on V2. But on a V1, it would scale up from here to here, go back, and then come down. So that's one good, scalability and a necessity in a way that it would scale up in minute levels, right? Fine granular scaling. All right. So another feature that is available with V2 is read-write scaling. Basically, there's a concept of router fleet. In router fleet, it holds the connections from the application, right? While allowing the capacity to scale without losing the client connection. So the client connection still stays with the router fleet, and then it routes back to the writers and readers, ensuring there is no loss of connectivity between the application or the client to the database, right? So that's one. And the other concept that I found interesting is mixed configuration, right? So a mixed configuration basically is if you have a provisioned instance, a regular Aurora now, you could add on a serverless fleet of reader instances to your provisioned instance without the need to migrate your data, without the requirement to create a new cluster, and so on and so forth. You can just use that as is, and then use a router fleet to manage the connections in the backend. So this gives us, a high scalable and with on-demand read capacity, basically. So this allows us to manage that with our existing provision instance cluster. Yeah. All right. So the last and final bit that I wanted to talk about is its pricing. So a couple of points here. So if you would see that one ACU unit R basically on V1 is 0.06 cents, as compared to on V2, it is almost double, right? Which would mean if if you do some math around it, if you needed 9 AC units, you would pay up more as compared to using 12 AC units of version 1, right? So, and again, its comparison with the provisioned capacity is also higher. So, of course, for the services that we get on the serverless instances, this is something where you would pay a price, and it would highly depend on the use case that you're using. So many would ask, should I use DynamoDB or should I use just provision instance? we should go with serverless. The decision factor is based on the use case that you're taking up to use this particular service. If it is for peak workload and most of the time your database is being used, then of course you don't need serverless. It is exactly for those 3 scenarios that I spoke about. And beyond that, any other scenario that you would take, cost is one factor that you should be considering. So I'm referring to these 3 scenarios, right? Which is spiky workload, infrequent workload, and periodic workload, so that you're not paying up too much for it. So with that, I would like to close. So yeah, as Mo introduced, Kaushik Mohanraj, part of Blazeclan, also an European ambassador and community builder. I'm happy to work with you guys.
Nice. Thank you so much, Kaushik. Actually, Kaushik, we just give him a very short notice for his talk, right? And he's, as always, he did a great job. I love it, man. But I still don't see a lot of people using Aurora, right?
Aurora, the general one, is still being adopted. As I said, the fastest adopted databases after Dynamo. Aurora provision instances is being used. Serverless, even until now, for version 1, we have actively advised not to use it for production workload because of the time it takes for scaling up and supporting production workload. It doesn't work well. So we have actively recommended our customers not to use version 1. But version 2, once it comes up, and if it has a right use case, I think it solves, it has a tick for all the issues that it had earlier.
Right. Any question, guys, related to Aurora in general? That's the right place to discuss this. Anyone maybe using Aurora at their company now?
Yes, I'm using.
So you're using the provisioned one or the serverless one?
Provision 1.
Okay, provision 1. Yeah.
Ah, nice. And is it like what they claim? It's faster and better.
Yes, we find it's quite faster, and the good thing is like easy managing. No need so much to manage it with it. Auto scaling the most important, so we don't like scratch our head all the time. Database under stress, peak hour, handle the timing for peak hour. So it's already handled by Aurora itself.
Yeah.
Right. And you just migrated to Aurora, or you just started with Aurora from the
We
beginning?
migrated last year, actually from Postgres to Aurora.
So Postgres on RDS to Aurora, is it?
Yes.
Okay.
No, and the price still almost the same, or it was quite more expensive?
Actually, about the pricing, I'm not sure.
Right, because you are not the one who paying, right? Right.
Yeah.
Thanks, Mustafa. Always nice to comment on these things. Dalain, are you still here? I remember Dalain wanted to migrate to Aurora, right?
I'm here, but I mean, the only way I'm gonna migrate if you guys give me 100K credits.
I already gave you free credits last time, right?
It's done.
Yeah, that's me. You guys are scaling and having more money now. Yeah. Any other question, guys, related to Aurora or anything? You can ask Kaushik. This is your chance for a free consultation from Kaushik.
I actually tried to get access to my free preview, but yeah, could not get that through before this session. I wanted to just try out some bits on that. But I would highly recommend you guys to look at the reInvent video on this. Highly recommended. It's a classic one where they showcase some details. I'm sharing the link here as well, right?
Yeah.
That's something that you should look at, and they have great case studies I've put in and shared some examples as well. Most of the data that I've gathered is from there, and another blog also around it, which is a good one. So I'll share that as well.
Nice. Kaushik, one question. So now if Aurora is better, faster, more scalable, right? So you in Blazeclan, because I know you guys have a lot of customer all around the world, right? So when do you choose I want to use RDS, and when do you say, okay, I'm choosing Aurora?
So I think by default, if the customer is not cost sensitive and is okay with to pay the price for better performance, we would choose Aurora as compared to RDS. But that having said, beyond that, for serverless, as I said, we have never recommended that to customers yet, right? And yeah, so that's the thing. So there are a couple of other things, which is database compatibility on what application they're using. So usually from scratch, new users who are adopting, so that's where we would use that as compared to an RDS who want to migrate onto that, or so on and so forth. So yeah.
Right. And do you usually recommend, if you are using for staging development environment, don't use Aurora, or doesn't matter?
I think Aurora is good, but slightly expensive based on how you utilize it. So that's the only point. So Aurora, I would recommend if you are using SQL, MySQL or Postgres, Aurora is a recommended thing to use, engine to use.
Nice, lovely.
Especially for the performances that you get with it.
Got it. Awesome. Any other question, guys, to Kaushik?
Yes, please. One question. You mean one question about V1 to do V2. So MySQL is V1. I want to transfer to V2. Is it like the difference is 5.6 to 5.7? Just to confirm this info.
So you're moving from MySQL to MySQL version to another version. Is that what you're saying?
Yes, MySQL Aurora from 5.6 to 5.7. So is it the same like I'm moving from V1 to V2?
Within Aurora itself, I think you can just do an upgrade once it is available on the thing. Once they support that version, you should be able to do an upgrade on the Aurora version itself. So, the regular Aurora that you're using, unless you want to move to serverless, right? If you want to move to serverless, you can do that, which is taking a snapshot and then moving it to serverless. That's about it.
Okay, that's good.
And vice versa, also it works, where you can take a snapshot from Aurora serverless and then go to your regular Aurora as well.
So V2, it's mean only serverless.
V2 is specifically for serverless only.
Oh, okay.
Yeah. Okay. Now I understand the question. Yes. So V2 is for serverless version only that they have launched in 2020.
Okay.
Yeah.
Great. Thanks.
So, and there are a few limitations. So, as I said, the maximum of 256 ECUs you could have it per instance, but under preview, I think it is limited to 32 ECUs, if I'm not wrong, for a thing. So, if you want to give it a try, I think you could do that.
Okay.
You can just register for preview and then test it out for sure.
Awesome. Any other question, guys? We still have time for more questions. If no questions, then we will jump to our networking sessions. We have people from all around the world, actually. Okay, thank you so much, Kaushik. And maybe you can run the demo you wanted to tell us, because you have access now, right? Maybe next time we can free, in our bus corner, right?
Yes, we could do that. Certainly.
Awesome. Thanks, Kaushik. Let me share my...
Yeah, we have the details for the next month as well. I've added that in.
Awesome. And you guys can reach anytime Belal and Kaushik through LinkedIn and WhatsApp, right? Not WhatsApp, LinkedIn and Facebook.
Yeah, definitely.
Yes.
Unless you guys don't want to. Yeah. Okay. Let me just refresh the page, because Kaushik just added for our next meetup.
The last one.
Okay. Guys, please, after we finish now the two talks, you can just scan this code very quickly and provide us your feedback. This is very important to improve the community and get a feedback from outside the team, right? So I will just leave this for a few seconds. If you can, guys, scan it, that would really be helpful for us. Yeah. And don't forget, guys, we are on Facebook. This is our main channel for like discussions, asking questions. We have people from AWS will help you, or from the community as well will help you answering your questions. And we have now a YouTube channel. We want to grow it. All the recording of our sessions are on YouTube channel. So if you missed one, you can just go back to the old videos and watch the recording. We are on Meetup, which this is our main channel where we send notifications and any update for new events. And Kaushik created a new group on LinkedIn as well, if you are active on LinkedIn. Before we stop the streaming on YouTube, we have two speakers for the next meetup. We have Varun. Varun gave a great talk last time, actually, about Docker, I remember. We really like it. So now he will come back with AWS SageMaker and will explain how we can do cool stuff on it. And we have another speaker, which is the first time we'll give in our meetup. His name is Omar, and we'll talk about machine learning and talk about all the cool stuff you can do with the machine learning, right? So stay tuned. It's gonna be on 18th March next month. I will send notification and keep following us on Facebook, LinkedIn, and Meetup. Salam, do you want to share anything before we stop the streaming?
All good. Yep, I can stop streaming.
Awesome. Let me just stop the screen. Nice. So guys, this is now our networking session.